So now let's talk about how we're going to graph a piecewise function. So once we get done evaluating it, again, we're going to find the domain, find your intercepts, graph, and then evaluate. So always do domain and range after you get done doing the graph. Graphs, domain and range is much easier to find after you get done doing the picture. All right, so now the way you're going to graph a piecewise function is the easiest way to do it is you make a table of values for each function in the piecewise function. So for example, for 2x minus 1, I'm going to create my x and y table for 2x minus 1. My second equation in here is 3x plus 1, and notice I'm going to create another table. So what you're going to do is you're going to fill x values into the table that fit into that particular function's domain. So for example, 2x minus 1. I'm going to fill in my chart for x values that are less than or equal to 1. So you always start the table with whatever the domain restriction is. So I'm going to start with a 1. Now, what is another x value less than 1? Fill in another x value. Another x value less than 1 is 0. What's another x value less than 1? Negative 1. And another x value less than negative 1 is negative 2. So now what I'm going to do is I'm going to plug in these values into my equation to find the corresponding y values. So when I plug 1 in for x, 2 times 1 is 2 minus 1 is 1. So the first point is going to be at 1, 1. Plug in a 0 for x. 2 times 0 minus 1 is a negative 1. 2 times negative 1 is negative 2. Negative 2 minus 1 is negative 3. 2 times negative 2 is negative 4. Negative 4 minus 1 is a negative 5. And you want to keep in your mind what shape or what does the graph of 2x minus 1 look like? Is it a V? Is it a U? What is it? What is 2x minus 1 graphically going to be? If you were to graph it, what would it be? Would it be a V? Would it be a U? What would it be? Hopefully remember what it is. A line. It's going to be a line. So now what I'm going to do is I'm simply going to plot these points. Now, this is where you want to pay close attention. Whether you have a less than or equal to 1 or greater than 1. You're always going to start both tables at where the domain is restricted. So now the question is, am I including 1 in this particular domain? Is 1 included in the domain? So when I graph this point, this is going to be a closed circle. Now, in my next table, I'm still going to start with 1. But now I want to fill in x values that are greater than 1. So what's an x value greater than 1? 2, and then what? 3, and then 4. So when I plug 1 in, 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, 6 plus 1 is 7. 3 times 3 is 9, 9 plus 1 is 10. 4 times 3 is 12, 12 plus 1 is 13. Now let's talk about 1, 4 for a minute. Is 1 included in the domain for 3x plus 1? No. So when you plot this point, it's going to be an open circle. It's just going to be a boundary point. You don't want to start your table at 2 because what happens is then when you go to graph it, you're going to be missing all of those x values between 0 and 1, all those fractions, 1/3, 1/4, 1/2. So this is just going to be a boundary point. So when you start your tables, you always start wherever the domain restriction is, but then you have to decide which one's going to get the closed circle versus the open circle. All right, so any questions on that? So now I'm ready to start creating my graph. So I'm going to go ahead and just plot my points for the first table. So 1, 1 again, I know is included, so it's a closed circle. 0, negative 1, negative 1, negative 3, and then negative 2, negative 5. So now what I'm going to do, remember, all of these x values are less than 1, so I'm going to connect all my points, and again, they're going on to negative infinity. So that's what the first part of the function is. Sometimes when I go to graph my second function, sometimes the piecewise functions are going to connect. They're going to share a point. Sometimes they're not going to connect. There's going to be a disconnect there. So now I'm going to go ahead and plot my next point. So at 1, 4, I'm going to put an open circle because remember that's my boundary point. And then all the other points will be closed. 2, 7. Yeah, I'll be off the graph a little bit here. And then 3, 10. And then 4, 13 will be all the way up here. So that is what this, so this is an example of a piecewise function that's not going to connect. Yes, Joanna?
I'm so confused on how to determine whether it's a closer to.
You have to look here, less than or equal to. So remember, less than or equal to is for this first function at 2x minus 1. Right? So that's why this is going to be closed. Closed represents it's included in there. That's what the closed means. So x greater than 1, notice x1 is not included in the domain, so that's just a boundary point. So 1 is not included, so that open circle means 1's not included in that particular function's domain. Okay? Does that answer your question, Joanna? Okay, so now let's talk about the domain. Let's talk about the domain. Remember, the first function, you're talking about x values when you talk about domain. So we have x values that are less than or equal to 1. We have x values that are greater than 1. What do you think the domain is going to be? All real numbers. So it's going to be negative infinity to infinity. Okay? You have x values less than or equal to 1. You have x values greater than 1. There is no break. There is no gap. All of those x values are included. But now you do have a problem with the range. The range are your y values. So notice if you look at the graph you create, and that's why you want to wait to do these until after you've done the graph. Notice I'm coming from negative infinity, and I stop here at this particular y value. What is the y value of this point? What's the y value of this point?
Y is less than 1.
1. Y is less than or equal to 1. But then, notice, is 2 or 3 included in the range? Are there any points that have a y value of 2 or 3? And then you have to pick the range back up at this particular point. So the range is going to be broken. So it's going to be negative infinity to 1 with a bracket, because you're including 1. And then notice the y value of this point is 4. But in interval notation, am I going to use a bracket or am I going to use a parenthesis to start this interval? Parenthesis. Remember, you only use a bracket, guys, if it's included. You're not including 4. 4 is not included in this range because it's a boundary point. It's an open circle. So you've got to use the parentheses right there. So any questions on how we did the domain and the range? X-intercept. How do you find x-intercepts? The x-intercepts are when y is equal to what? When y is equal to what? 0. So look at your graph. Which function would have the y-intercept? Is it the first function or the second function? The first one, this one. Notice this is the line that's crossing the x-axis. So to find your x-intercept, you're going to have to set the first equation equal to 0. So 0 is equal to 2x minus 1, so x is going to be equal to 1/2. So your x-intercept, remember, it's a point, 1/2, 0. The y-intercept is when what is equal to 0? The y-intercept is when what is equal to 0? X. So when x is equal to 0, again, you're still looking at the same function. This is the graph that's crossing the y-axis. On your table, you've already found the y-intercept. What is the y-intercept? 0, -1. Okay? Remember, I don't care what kind of equation I've ever asked you that you ever have to graph. X-intercepts and y-intercepts don't change. To find an x-intercept, you set y equal to 0. To find a y-intercept, you set x equal to 0. That has not changed since back when you were doing lines, all right? Questions on that? So now evaluating. F of 1. So again, remember, this 1 is an x value. You have to look to see which domain 1 fits into. Which domain does 1 fit into, the first equation or the second equation? The first. So I'm going to plug in 2 times 1 minus 1. So f of 1 is equal to 1. Look at f of -2. Which domain does -2 fit into? Does it fit into the first equation or the second equation? First. So 2 times -2 minus 1. So -4 minus 1 is a -5. 4. Which domain does 4 fit into? Does it fit into where it's less than 1 or where it's greater than 1? Greater than 1. So I'm going to plug it into my second equation. So 3 times 4 plus 1, so that gives me 13. So any questions on how I graph the piecewise function, or evaluated or answered the domain or range questions. But again, domain and range, the easiest way to do domain and range is do the graph first. Okay? Questions on that? Let's look at another one. Let's look at 1/2 x plus 3/2 for x less than 1, x greater than or equal to 1 for negative x plus 3. Again, easiest way to do a piecewise function is you make a table for each equation. So there's my x and y table for the first equation. What x value am I going to start my table at with this? I'm going to always start with the domain restriction, wherever that domain restriction is. So what x value am I going to start my table at for this first equation? What's the first x value going to be? 1 or 0? 1. So what's another x value less than 1 then? Another x value will be what? 0. Another one will be what? Negative 1. And then another one will be negative 2. So do about 4 points always. So now I'm going to plug them in. So 1/2 times 1 is 1. 1 plus 3/2 is 4/2, which is just going to give me 2. Plug in 0. 1/2 times 0 is 0. 0 plus 3/2 is 3/2. Negative 1 times 1/2 is negative 1/2. Negative 1/2 plus 3/2 is going to give me 2 over 2, which is just 1. 1/2 times negative 2 is negative 1. Negative 1 plus 3/2. Remember, I need that common denominator. So negative 2 over 2 plus 3/2 is going to give me 1/2. So now I need to do a table for my next function. I need to do a table for negative x plus 3. What x value am I going to start with this table? Am I going to start with a 1 or am I going to start with a 2? What x value do I start with in the second table? 1. What's another x value greater than 1? Another one's going to be what? 2, and then 3 and 4. Plug them in. Negative 1 plus 3 is 2. Negative 2 plus 3 is a 1. Negative 3 plus 3 is 0. Negative 4 plus 3 is negative 1. So now the question is, looking at these first points in each table, which one's open and which one's closed? So take a look at the first equation. At this 1, 2, what kind of point am I going to plot? Is it going to be open or is it going to be closed? Open. In the negative x plus 3, remember, x is included, so this would be a closed. So now let me start plotting points. So let me do my first table. So I have 1, 2. That's open. 0, 3/2 is about 0, 1 1/2. So you just have to estimate the best you can. Negative 1, 1. Oh, and I put that in the wrong spot, right? Wait a minute. 1, 2, 0, 1 1/2. Negative 1, 1. And negative 2, 1/2. So any questions about the first part that I plotted? Now, when I go to plot my second table, I have to plot the point 1, 2. And you just told me it was closed. So what happens is they're sharing that point. That ends up filling in that point 1, 2. So like I said, some piecewise functions that they connect, they're going to share that common point. So you don't know, if you're just looking at the graph, you won't know which one would be open versus closed. So this 1, 2 gets filled in. And then you've got 2, 1, 3, 0, 4, negative 1, and then negative 2, 1/2. Wait a minute, did I do something wrong there? Yeah, 4, negative 1, there we go. Okay? So what happens if you have a piecewise function that connects, that open circle ends up getting filled in. All right? So any questions on the graph of this particular piecewise function? So now let's talk about the domain. You can either look at the graph or you can actually look at the inequalities that are given. That's pretty much the domain. X is less than 1, X is greater than or equal to 1. Are there any X values that are not included? So what's the domain of this function going to be? Negative infinity to infinity. What's the range going to be, though? The range is coming from negative infinity. The highest point on the graph is right here. So what's the y value of this particular point? 2. So it's going to be negative infinity to 2. X-intercept. Remember, the x-intercept, look at your table. The x-intercept is where the y is equal to 0. So what is your x-intercept going to be? It's going to be 3, 0. And then the y-intercept is going to be when x is equal to 0, so that's going to be at 0, 3/2. And I realize I accidentally did the graph on the graph for number 4. Sorry about that. So that goes with that. This is the graph for number 3. Sorry about that. You guys go ahead right now and evaluate this piecewise function. So you go ahead for number 3, evaluate the piecewise function at those 4 particular values. So hopefully we came up with those values right there. All right, any questions on number 3, whether it's graphing the piecewise function or evaluating? All right, I'm going to skip over number 4 because I want to go over and do some on the next page because, again, we've done 2 with just lines in them. So sometimes with piecewise functions, guys, instead of just having 2 equations, you may have 3. Again, if you have 3 different equations, you make 3 different tables. You make an equation for each particular graph. So, for example, we've got an equation in number 5 that's just negative x squared. What's the shape of negative x squared, by the way? U. It's a U shape. So when you go to connect your points, you want to make sure, keep in mind that it's a U. You're not going to draw a straight line when you connect those points. All right? So, again, I know it's a parabola opening down, and where's that vertex going to be? Is there any shifts here? The vertex of this parabola is going to be at what? 0, 0. So there's no shifting. So keep that in the back of your mind. So when I make my table for negative x squared, here's my x and y table. What x value am I going to start at? I'm going to start at an x value of what? I want x values less than negative 1. So what x value am I starting in my table? I'm going to start at what? Negative 1, negative 2, negative 3. When you have this many, just go ahead and do 3 points. That's fine. Okay? Now be careful. Don't make a careless operation mistake. Am I squaring the negative sign in front of this x? No. Remember, there's a difference between this versus this. They're not the same. So be careful, guys. You're not squaring the negative. You're just squaring that particular x value. So when I square negative 1, that's going to give me a positive 1, but I have the negative sign in the front, so that's a negative 1. When I square negative 2, that's a positive 4, but I still have that negative sign in the front. When I square negative 3, that gives me a 9, and the negative sign in the front is a negative 9. And it's kind of an eeny, meeny, miny, mo. It's up to you. If you want to do all 3 tables and then do the graph, or if you want to start sketching your graph after you do a table for each function, that's completely up to you. So look at this first point at negative 1, negative 1. When I go to create the graph, would this point be open or would this point be closed? Open. Because remember, negative 1 is not included in the domain because it has to be less than negative 1, not equal to it. So at negative 1, I know it's open. Negative 2, negative 4. And then negative 3, negative 9 would be down here. Again, remember, like I said, your vertex was at 0, 0, and it's a U opening down. So when you go to connect these points, I know it's kind of hard, you want to make it so you have a little bit of a curve there. Because if you were to sketch the entire U, you know it would kind of be part of your U. So now I've got, what does the graph of y equals 1 look like? Because if you look at your second equation, it's just 1.
It's a horizontal flat.
It's just a horizontal line. All of the y values are going to be 1. What x values am I going to fill in here? I've got -1, 0, 1, and 2. So this domain is only going to go from my x values from -1 to 2. And all the y values are 1. What's happening at -1, 1? Is that going to be an open circle or a closed circle? Closed, because the -1 is included in this domain because of the equal to part. So I have -1, 1, 0, 1, -1, 1, 0, 1, 1, 1, and then 2, 1. Now, be careful. What's happening at 2, 1? Is that going to be an open circle or a closed circle? Is 2 included in the domain for this part of the function? No. So notice this part's going to be open. So when you've got these three functions in there, this one in the middle that has that compound inequality, be careful. One may have an open circle or a closed circle to start, and the other one will be different. So any questions so far on what this function looks like? So then I have the function x minus 3 squared plus 2. What is that graph going to be? What does it look like? V, U, line, what is it? It's a U. And I've got a transformation here. Where's the vertex going to be for this particular U? It's going to be at what? What's that minus 3 doing to the parent function? It's moving it where? To the right 3. And what's that plus 2 doing? It's shifting it what? Up 2. So I know the vertex is going to be at 3, 2. Again, I'm going to start my table at 2, 3, 4. And again, you just told me the vertex was at 3, 2. So now plug 2 into this equation. So 2 minus 3 is -1. -1 squared is 1, and 1 plus 2 is 3. I already know the vertex is at 3, 2. Plug in 4. 4 minus 3 is 1. 1 squared is 1, and 1 plus 2 is 3. What's happening at 2, 3? Is 2 included in this third function's domain, or so is it going to be a closed circle or open circle? Which one is it going to be? Closed. So I have 2, 3. Then I have 3, 2. And then I have 4, 3. So now remember, you just told me this is a U shape. The vertex is at 3, 2. So that's what that particular piecewise function is going to look like. Okay? So this is an example where you have a piecewise function with 3 equations and there is no connection to all 3 parts. That's why doing the tables are the easiest way to build a piecewise function when you're doing the graph. Any questions on number 5? So tell me about the domain. You have x values that are less than -1. You have x values including -1 less than 2. You have x values that are greater than or equal to 2. Are there any x values that are not included in this particular domain? Are there any x values that are not included? Yes or no? No. So what's that domain going to be? The domain is going to be what? All real numbers. Now let's talk about the range. You can see because there's no connection, you are going to have some breaks in the range. If those piecewise functions don't connect, you're going to have some breaks in the range. Remember, read a graph lowest to highest. So I'm coming from -infinity. Notice the graph stops right here. So part of my range is going to be from -infinity, and what's the y value of this point right here? The y value is what? -1. Am I including -1 or not including? So it's going to be a parenthesis or bracket after -1. Parenthesis. Now notice the next part of the function is right here. What are all the y values on this horizontal line? All the y values are what? 1. So I've got to include the ones in just a single bracket by itself. And now look at the next part of your piecewise function. The lowest point on this part of the piecewise function is at a y value of what? A y value of 2. And it's going to positive infinity. So it's going to be a bracket 2 to infinity. Is there any part of the graph that crosses the x-axis? No. So is there an x-intercept here? No. Is there any part of the graph that's crossing the y-axis? Yes, right here. And where is it crossing the y-axis? It's crossing at what? 0, 1. Remember, make sure you write them as ordered pairs. So any questions on the domain range or x and y intercepts there? You guys go ahead and evaluate at -2 and 7 for me. Values for the piecewise function. Again, remember, -2 fits in the domain where x is less than -1. So you're going to plug -2 into the first equation. 7 fits in where it's greater than or equal to 2. So you would plug 7 into the third equation. Remember, you don't plug the values into all three. You've got to figure out at the number you're plugging in, which domain does it fit into. All right, any questions on number 5? Let's take a look at number 6. Again, you've got 3 different functions in here. But what's different about this one is take a look at the very last function. Notice this is not an inequality. It's saying when x is equal to 3, the y value is 5. So graphically, it's not a line, it's not a U, it's not a V. Sometimes in a piecewise function, they will give you a random point to plot somewhere on your graph. So where you see a single x value and then just a single y value, this is how you know you're just going to have a random point plotted on the graph. That's what a point is going to look like on a piecewise function. So I know I'm going to have the point 3, 5. And again, it's going to be closed because it's equal to 3. So at 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. So you don't need to worry about building a table, you just plot that point. But that's what a point is going to look like in a piecewise function. So any questions on that? So now let me build my table for x plus 1. Again, x values are less than -3. So what x value do I start in my table? I'm going to start at a -3. What's an x value less than -3 then? An x value less than -3 will be 4, -5, -6. Plug them in. -3 plus 1 is a -2. -4 plus 1 is a -3. -5 plus 1 is a -4. -6 plus 1 is a -5. Tell me about this very first point at -3, -2. When I plot it, is it going to be open or is it going to be closed? Open. Next point will be -4, -3. -5, -4. So there's the first part of your piecewise function. What's the graph 1 over x look like? Remember your lovely rational functions, vertical asymptotes, horizontal asymptotes. Remember what the graph 1 over x looks like? Again, it's on that page 14 in your notes. The whole purpose of that one page I had you fill out, that library of functions, I gave you a reference to what all those parent functions look like. Where's the horizontal and vertical asymptote for 1 over x? Not page 14, I'm sorry. It was page, remember I had you do this page 4. Page 4, I knew it had a 4 in it. That's the whole purpose of page 4 in your notes, guys. So if you forget what a parent functions look like, you have it as a reference page. Remember, 1 over x has a horizontal asymptote at 0, vertical asymptote at 0. This is where you've got the graph that looks like this. You have the key point at -1, -1, and 1, 1. That's what the graph of 1 over x looks like. Okay? So now when I go to build my table for 1 over x, I'm going to fill out x values from -3 to 3. So -3, -2, -1. Can I include 0 in this table? No, because notice, remember, at 0, 0, you've got asymptotes. So then I'll fill in 1, 2, 3. So when I plug in -3, that's -1/3. negative 1/2, and then negative 1. At 1 over 1 will be 1, 1/2, 1/3. So now tell me, before I start plotting 1 over x, tell me what's happening at the point negative 3, negative 1/3. Is negative 3 included in the domain for 1 over x? Yes. So what kind of point am I going to plot? Is this going to be open or is this going to be closed? Closed. Take a look at the last point. 3 1/3, because notice this domain is not going to infinity, it's stopping at 3. Will this be an open or a closed circle? Open. So again, negative 3, negative 1/3, you just have to estimate the best you can. You know it's close to that x-axis. And then you have negative 2, negative 1/2, and then you have the point negative 1, 1. And remember, the graph is going to split, because 0, 0 is not included. Again, now, even though we did not include those values in the chart, remember, this graph gets really, really close to your y-axis going to negative infinity. Because that's, remember, what the parent function looks like. Next, you've got the point at 1, 1. You've got 2 1/2, and 3 1/3 with an open circle. And again, remember, this graph goes up towards your y-axis, towards positive infinity. It's an interesting piecewise function, yes. You'll see some crazy ones, especially if you take calculus next year, you're going to see some crazy piecewise functions. But again, build your table and just remember what those parent functions look like. All right, now let's talk about the domain. Starting from negative infinity, x value is less than negative 3. Is negative 3 included in the domain? Yes. Where's this domain stopping? It's not going to go all the way to infinity. At what x value is this domain stopping? It's stopping at what? 3. Is 3 included in the domain? 3 is not included in this domain, but 3 is included in the domain right here, isn't it? Because it's where that point is. So then my domain is going to be, remember, all real numbers except 0, so I've got to stop it at 0, because remember I have a vertical asymptote at 0, and then I'm going to go from 0 to 3. Now the range, be careful, you've got to read the whole graph together, lowest to highest. So I'm coming from negative infinity, and I'm getting really, really close to 0, but I can't be equal to 0, correct? And then the graph picks up, it's going to be greater than 0 to infinity. So the range is going to be all real numbers except 0. Do I have an x-intercept? No, because remember you have an asymptote there. Do you have a y-intercept? No. F of negative 6. Where does negative 6 fit into? Which domain does negative 6 fit into? The first, second, or third? First. So negative 6 plus 1 is a negative 5. Now 0, remember, is between negative 3 and 3. But what happens when I plug 0 into 1 over x? That's going to become what? Undefined. So it doesn't exist. All right? So any questions on how you handle a piecewise function? All right? You guys go ahead and see if you can build your tables. And we'll do the graph together, but see if you can do your tables for number 7. So go ahead and do your tables for number 7. So hopefully we got tables that look something like this. Again, 3 functions. Remember, what does the absolute value graph look like? What shape is that going to be? That's going to be a what? A V. Where's the vertex of that V going to be? What's that minus 2 doing to the parent function? It's going to shift that vertex off of 0, 0 to where? It's going to go to the right, 2. So I know the vertex of this V is going to be at 2, 0. 2x minus 1, what's the shape of this? This is going to be a what? A line. Square root of x, we know that that's that, looks like half of a U sideways. Okay? So now let's start plotting the points again. At negative 2, 4, always, again, when I build my table, I kind of circle those points I have to be on the lookout for to decide whether they're open or closed. Remember, this represents x values less than negative 2, so at negative 2, 4, it's going to have to be an open circle. And then I have negative 3, 5. And then I have negative 4, 6. Again, that's just part of my V. I know eventually it hit my x-axis at 2, 0. So it does look like a line right there. 2x minus 1. At negative 1, negative 3. Negative 1 is included in the domain for 2x minus 1. So I'm going to put a closed circle at negative 1, negative 3. 0, negative 1, and then 1, 1. Again, 1 has to be less than 1. It's not equal to 1. So at 1, 1, it's going to be an open circle. And then square root of x, again, it's for x values greater than or equal to 1. So 1 is in the domain, so this is going to be a closed circle. Again, that's going to fill in the hole right there. And then 4, 2. And remember, it looks like that half of a arc right there. Is the domain going to be all real numbers for this one? Look at your inequalities. You have x less than negative 2, but then it doesn't pick up until x values greater than or equal to negative 1. So the domain is not going to be all real numbers. It's going to be from negative infinity to negative 2. And then it picks back up and goes from 1 to infinity. The range. The lowest point is happening right here at this particular y value. So that's happening down here at negative 3. And I am including negative 3. Now remember, you've got to put all the pieces together when you're reading the range. Even though this is not increasing dramatically, it is going to positive infinity. There is no break in the range because this point is connecting right here. So it's going to be from negative 3 to infinity. The y-intercept you can read from your table. The y-intercept is right there at 0, negative 1. And again, which function is crossing the x-axis? It's crossing the x-axis between negative 1 and 1. So remember, to find your x-intercept, you have to set y equal to 0. So you'd have to set the 0 equals to 2x minus 1. So that's going to be at 1/2, 0. Okay? So any questions, guys, on doing piecewise functions?